there yet.
Chapter 4.
Yeah.
Input output devices, and then of course motor controls. Identify the chapter 3 is number system, so that's what
Oh,
we
okay.
do.
Okay. All right.
Identify electrical symbols from various switches, describe the operation of Hall effect, ultrasonic. We might kind of skip over that right now and come back to it later. What we need to do is actually look at the what's going on. First of all, guys, I wanted to make sure that y'all understand the difference between what we call a modular PLC and then a fixed PLC. So what we have over here on my right is a true modular PLC. It is a Allen Bradley 500 series.
Logic.
Yeah.
Logic. Logic Pro.
Well, no, Logic Pro is the name of an application that we use.
Okay.
So what we have, a modular PLC, first of all, it's mounted in what we call a rack. So you're actually looking at a rack. And then the first thing that goes into the rack, it doesn't occupy a slot number, is the power supply. The power supply. 24-volt power supply. In the next slot, which is slot 0, so you have things in computers, you got to understand when you start everything with 0. The analogy we use, a football player run out on the field, he's got the number 0. That means that no one is this, right? A slot 0, this is actually where the processor's at. By the way, they call it so we've got a 504 CPU. So we use refer to this for 504, so 504. This has got a switch on it, which is pretty nice because what we do with the switch is we switch it between programs. We can execute it with the program. We can switch it to run. We can tell it to run the program. Tell the PLC to run the program. And then we have another position on this PLC called remote, and that means you can do it from your computer. You can actually switch it between those two modes. Now, what's nice about these is that you take the key out and somebody can't do it. Yeah, if you got it run, they can't come in. Also, on CPU, we'll get this way that we can get the computer connected to the computer, so these guys don't use dedicated programs. This file PLC that I've been involved with, you have an application installed on your computer. Somehow you connect to the PLC, and then you download it to the PLC or upload it to a program. This is using one called data highway. This guy right here. So I would plug this in. It's actually using an interface that's kind of obsolete. Down Brown is still like it's called RS-232. It's the IEEE standard. I'm sorry, it's the IA standard. IA involved another standard place called TIA, which is the Telecommunication Association. They went over and adopted the RS-232 standard. You'll see it TIA, RS-232. All it is a physical wire of this cable and what connectors that we use to actually use a connector called a D9, and it used to be call it DD. It's in the shape of a D. And then the female connector is up on a plateau, and the male connector has a shell around it. So what that means is you can't plug it in backwards. I don't know if you've heard about Murphy's Law. You have to read your law with Murphy's Law. Yeah, and basically, it's no wrong. I don't think anything that can go wrong will go wrong. So that's pretty much how Murphy's proof unless somebody gets out of criminal. But that's off the shell around the outside. Unfortunately, we don't have this interface on our computer anymore. What internal interface is to make a connection to. So we have to make a connection to the computer through a portal, right? We talked about that a little bit. The old the DVD or the RS-236 is no longer available. It's a relic. So some of those back at the back are going to get rid of in the lab. We go down, you'll go back and you'll have an RS. What's everything going to? Well, let's see. We're talking about our own devices.
USB.
Yeah, that's what it's going to. So what we have is we buy a dog. We have a dog. And basically converts RS-232 over. I'm sorry, USB over to RS-232. So on all our computers, you'll see that. So the interface is actually going to be on the module, how we connect to it. Right. We have slots, and the slots, right? In the back of the slot, we'll see the connector, This is referred to as backline. So we plug that in, it slides into that backline. That's where your module picks up the power supply. So that's where it picks up the power supply. It also picks up its address. And how do we address that slot, that module? Comes down that backline. So first thing, we'll show you all the address. We can't always got as far as that. So what we have here, the first module, if I can get this man.
Oops, caught my camera.
Okay, there we go. This is a input module. Got 16 bits, so it's a word, right? You notice there down here at the bottom it says PC sync. We'll talk about that in a minute. And then this is the output module. Got 16 outputs on it, single bit output, right? Understand that. And then of course this is a 7-slot rack, so we can put 7. Right now we got this would be 1. This would be slot 2. The next slot, if I stuck a module in there, it'd be slot 3, slot 4, slot 5, and slot 6, right? Does that make sense? So right now we've only got 3 of the slots occupied. See, I can actually see the position on the switch. Right now we have it in program mode, so we can do one program. And normally what we do is we switch it to remote. That way you can do it through the application. You don't have to do something to switch. Okay, there. This is let me call it so this is the way on this one. This is what we would have to learn how to do. Actually, how we connect and put it out to this 5. So when you look into this, you see it's just a bunch of wires that we have to know how to hook it up, right? We're not going to be doing any wiring in this class. But what we will be doing is we'll be drawing the way we would hook stuff up in this class. Okay. This is a fixed PLC. Some of y'all are going to be doing this. We're not using this anymore. The interface that's on it is when the RS-232 first came out, the speeds were really, really slow. So I can't remember what this one is, but it's so fast. I mean, this guy's slow. The communication module on this one's slow, so we're not going to use this one. This is the one some of y'all are going to be doing. This is a true fixed PLC. This is the MicroLogic 1000. I'll get all time of it. This is MicroLogic 1000. And what you'll notice on most of your PLCs, they'll have these LEDs on there.
that will actually show y'all, will show you when the inputs are active and when the outputs are active. Okay. This is the actual input ports. We'll show you how we can wire this up. Okay. And this has, it's got inputs 0 through 3 and then 4 through 9. So this has 10 inputs on it. Okay. Everybody okay? And that's important to know because that's what we have to know to actually address this one right here. And notice it's got two right here labeled DC common. Can you see that? Yeah, right here. Yeah, well here the power supply is not internal. It has a power supply on it. Here's the output right here. So it says 24 volts plus or minus and it says DC out. Can you see that?
Yeah.
And then you can see what I've done is I've taken the minus and run it to this DC common. And then we've got this jumper right here that's taking it and jumping down to this DC common. So this guy right here is using a minus as a common. Okay. This guy has relay outputs.
That's a cold relay.
Huh?
It can be a cold relay. Like at the bottom of your inputs and outputs connected to a cold relay.
Yeah, but it's internal. You don't know it. You can hear it clicking. So this one, every time you generate an output, you'll hear a little click.
Okay.
And that would be you can't see the relays because the relays are inside the PLC.
Okay.
The PLC.
I got you.
When we say it's got relay outputs, we mean technically the outputs are part of the circuitry built into the PLC.
Okay, got you.
What's nice about PLC outputs is that we decide what we use as a common. So this guy's got 6 outputs, 0 through 5, and then it's got a common for every one except for 4 and 5 looks like it shares the same common. I need to look at that. And you can see it's jumping all the way down the line. And this is where this is where the power supply is actually wired to. This is 120. We can put between 85 and 254 volts in here. And then we take what we call L2, which is considered to be the common, and then it's run all the way down here. So guys, these outputs output 120 volts. So I don't want to see, when you're down there, I don't want to see this cover opened up on this, right? Makes sense. Yeah, you'll be. Of course, on a trainer, we simulate sensors, because most sensors we have, and y'all that was here last class, we looked at some of the sensors on the line over there, right? You know, that can sense metal and all kinds of stuff. We're going to just kind of simulate it. So what we have here is we have a bunch of push buttons. And then we have a bunch of lights. So these are lights right here. So these lights are hooked up to the outputs, and then the push buttons are hooked up to, the switches are hooked up to the inputs. And then we have these toggle, no, these are not toggle switches. We have these selector switches on here too. Are we okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So some of these must not be hooked up because we've only got 10 inputs. I think all of these are hooked up, so something down here might not be. So this is a fixed PLC. Now what advantage is there to a fixed PLC? Huh?
Everything changing.
Everything's built right there.
What's that? Well, they all set up basically the same. We'll look at that. Fixed PLCs are the cheapest. They are not expandable. You get what you pay for, period. I cannot add inputs. If I need more inputs, I cannot add more inputs. I cannot add more outputs. I cannot add analog to this. I can't add anything. I get what I pay for. It is not expandable. This guy over here, this is totally expandable, right? I decide what modules I buy for these things, right? You understand? So the big advantage of the modular PLC, it costs more, right? You understand? But it's very expandable. And it's also cheaper to fix, right? So it would be, so a module would cost less than this PLC right here. right? You understand that? So if I lost a module, I could buy a new module. If I lost one of the ports on this guy, I'd have to buy a new PLC. So modular PLCs are more expensive up front. The big advantage of a modular PLC is you get what you want. You're not trying to go out there and find a PLC that has what you need. It gets what you want, right? So right now when you go out and buy a phone, it is not expandable. So you buy the phone for what you want, right? You understand? Now, some people buy the most expensive phone out there. So you'd be the kind of guys that walk in to buy something and tell the guy you want the best they got. And the salesman kind of smiles, you know. I'm going to make a lot of money off it. And then we have some of the newer PLCs that basically comes out. So this is 1100. Some of y'all will be working with 1100. You know, oh, no, I'm not on the camera. Sorry. So this is Micrologic 1100. They started out by actually showing the input. So it's got an LED screen on it that's not backlit, which gives us some problems. Instead of having the LEDs that come on front, they actually change the appearance of a little square on there. So you got to look at this one in the right light. So this was the only one that Allen Bradley went out where they put the LCD screen on it. They all went back to the LEDs because they show up a lot better. This is so by the way, this is not the PLC. So y'all do one of the first labs we're going to do is you're going to specify what's on your PLC. This is not the PLC down here. This is a thing that we mount the PLC on, right? So this is the PLC. So that means when I ask you how many inputs your PLC has, don't put 16 on there because I'll mark it wrong because that's the inputs I have on this. It's called an EduTrainer. We can mount all types of PLCs on this. Eventually, this is what we're going to be going to because we decide what PLC goes on this thing. So we could put a Siemens on here. I'll bring a Siemens over here, by the way. We're going to show you all the difference. Just to let you know that what you're learning it can apply to also Siemens. This guy has a certain number of fixed ports on it. It's got inputs from 0 up through 9, so it's got 10 inputs. Outputs, it's got 0 through, I can't see. It's got 7 outputs on it. But it's got this little thing on the side. And we don't have any modules for it. But what we can do is we can pop off this cover on the side, and it's got a connector on there that basically serves as the backplane. So what we did with these guys is we get a fixed number of inputs, we get a fixed number of outputs, but we can still do what? We can still expand it. So this is most of your smaller PLCs are going to this guy. You don't see many fixed PLCs unless they're really, really, really cheap. So these would be like mid size, right? Not extreme. So these are the two that we're going to be using. Some of y'all will be on the Micrologic 1000, which are fixed PLCs. And it's going to be great for this class. And then some of y'all will be on the 1100s, which are, I call them hybrid PLCs. Some people still call them modular. But what I want to tell you is it's a fixed PLC, but you do have the ability to do what with it? And you can expand it, right? Yeah, you just pop this cover off, and then you can put a memory card in here, and then it mounts on this guy called a DIN rail, and it just snaps on. Y'all can't see those tabs on the bottom. So all I'd have to do is just put a screwdriver in here on the bottom and pop these tabs down. I could pull that PLC off. Something that this PLC don't have that most of your PLCs are going to now is that the terminal board is actually removable. So the only problem we have with this guy is if the PLC went bad, I'd have to totally rewire it. When I bring one of the 1214s over here, Siemens, and also the newer Allen Bradleys, the terminal board is actually removable. You can pop it off, and that way you can put the new PLC in there and just pop the terminal board back in there and out without doing any rewiring. You know, it is, and it's really, really. So the Compact Logics, which is the next version after the Micrologic, they have the removable terminal boards, and also the Siemens PLCs that I'll bring over and show you. I don't think I have one over here tonight, don't you? So we have two types of inputs. The only inputs that we're going to use is we call them Boolean inputs, or Boolean inputs, or BOOL is what most of them shorten it. What we hook up to our inputs, of course, is we hook up actually physical devices, right? To understand that. And when you hook them up, when you draw your diagram on the hookup of your physical devices, you're supposed to use the electrical symbols that actually represent those devices. So right now we've got push buttons. We have normally open push buttons. This is not a normally closed push button. This is a normally closed. No, this is not right. This is wrong too. Is this symbols in y'all's book? I don't know what figure it is.
Yes. Your symbols in the book.
Does it call this symbol right here normally closed, held, open?
Normally closed.
The problem is that the author here just don't separate things as much as it's supposed to be drawn. So basically, this right here should have been drawn like this. It
Yeah, that's the wrong way.
should have been drawn like that. And then we might have a normally open, held, closed. It should be drawn like this. Manual switches require an operator to change states. So what PLCs does not do away with manual switches. Y'all understand that? Automatic switches, these are going to be our sensors. They're either going to be manually operated. I think we looked at limit switches, and either they're going to be proximity switches. So proximity switches is a term we use for non-contact sensors, which means they don't have to make physical contact with what they're trying to measure. Are we okay? So we looked at this already, right? The single pole, double throw. This guy don't draw them quite right. This is probably the way you're going to see them drawn. So this would be what we call a single pole, what? Double throw, right? This is what we call a double pole, double throw, right? Are we okay? This is drawn wrong. So this would be, if it's, but what you're doing is you're looking at what gravity wants to do with them, right? Understand? So here gravity wants to close them, so that must be a normally open switch, right? Are we okay? Momentary contact push buttons, that's what these are up here on this trainer. Most push buttons are what we call momentary contact, which means what? Well, they could be normally closed or they could be normally open, but they're momentary, which means they got a spring in them. So they're in one state, they're either normally closed or normally open, and they change states when you push on them, but as soon as you let them go, they do what? They go back to their original state. Then we have latching push buttons. A lot of your e-stop buttons are latching push buttons. A lot of them. Ours are not. So y'all don't have them. These e-stop buttons up here, they are latching, I'm sorry, on these disconnects right here. I'm not sure about the blue ones though. But some e-stop buttons are not. These are latching, which means you push them in, they latch down, and you gotta do what?
Push it back up.
Pull them back up. A lot of your e-stop buttons, by the way, you actually have to turn them and pull them out.
Mm-hmm.
So that means you can't accidentally, you gotta deliberately pull them out, right? So here's some push buttons. This is not in your book. I just got these off the internet somewhere. So normally if it's got a mushroom head on it like that, that's usually an e-stop button. But we have button assemblies. This has two buttons in them. We still like a lot of mechanical buttons. A lot of things are going to simulated buttons using what we call an HMI panel. You know what HMI stands for? Yeah. So an interface is a term we use in computers all the time. It means make a connection too. So we call these HMI panels. These are the touchscreen panels, kind of like your cell phone that you have as a touchscreen, except they don't use capacitive like these do. These usually use what we call resistive film because they don't want you to accidentally hit them, right? So these you literally got to push in on almost like you will a real push button. And a lot of it's going to simulate them. Poles, these are the number of switches that we are controlling. And then throws are the number of conditions that the switch can be in to control something, right? Understand that? Yes, right.
Can you repeat that?
The poles are the number of switches being controlled by the same operator. That should probably be best. The throws are the number of positions the switch can be put in to control a circuit. So this right here, that would be one switch controlling one circuit. So this would be a what? Single pole, single throw. If I came over and did this, then this is two circuits, right? You understand? One switch, so this would be a single pole, double throw.
Okay.
That makes sense?
Good.
And then if I came over and did this, and then I put a symbol that says these are mechanically connected together, and what it is, it's a dashed line. So those, all I would see is one switch, right? You understand? This would be a double pole, but each one of them can only control what? One circuit. So that'd be a double pole, single throw. Two poles, I'm controlling two switches, but each switch can only control one circuit.
Okay. Let me-
I'm running out of space. And then I put the dash line. It means they're operated by the same operator. You're not going to see two switches.
Okay.
All you're going to see is one. If it was a switch, you'd see one switch. If it's a push button, you'd see one push button. But when you hit that one push button, it's actually controlling two switches, right? You understand? So this would be a double pole. And then each pole has two positions. So this would be a double pole, double throw. Double break, single break, double break. Most of the contacts, not all, but most of the contacts on these push buttons are like this. So we'll have a set of things down here, and then if this is a normally open, we would come over here and we'd have another one up here. Okay. So what happens, and then we might have a spring under here because this is a normally open, and then I might have some type of operator. And so what happens, and then my circuit would be across here, right? Yeah, that makes sense? And then when I push the button down, it makes a cut. This is what we call a double break. Now, a single break would actually be that symbol right there. So a single break would be like this. Now, what advantage does a double break have over a single break? So just about most of your relays, especially your high current relays, are going to be double break contact. Got one normal, got one set of normal, one set of normal open. And these are double breaks, so these guys can handle quite a bit of current. Thought they wanted to do that. And I'll pass this around, which I'll actually look at it. So this is the solenoid. So what we do on a, let me get over. So this is the solenoid. most of the industrial relays encapsulate the coils inside plastic because the wiring, I think I passed my little coil around to you, the wiring is so thin that if you actually hit it, you nick the insulation off of it. And these guys are replaceable. We could pop this thing out right here, take this screw, we could take this screw out right, let me get this, we could take that screw out over here and the armature would pull out and then I could pull the actual solenoid out and replace it. So a lot of your industrial relays are actually repairable. We are getting away where the actual contacts are exposed. Normally now they'll have a cap or something on this to keep an accident to do it. So these are double break contacts. So if it focuses in on it. Yeah, so right now this one's open. Notice now it's closed. You can actually see the spring under it. And then this right here on this side is already closed. If I can, let's see what this stuff. So these are normally closed if I can get it in there. And then when I actuate, they're going to break. Now these are double break contacts. This is the armature. Some people call it plungers, and this is a relay. So a relay is an electrically controlled switch, right? So this would be double pole. Why would it be double pole? Because I got two sets of contacts controlled by the same operator, and each one of them is only controlled in one thing. And so these would be single pole. So just about all your relays are single pole anyway. Single pole. So single throw. So most of them would just give you the number of poles that have it. So what advantage does double break have over single break? So these are double break contacts. I can show y'all some push buttons too that are double.
Double has two contacts and single have one.
Yeah, but why do we need two? What would be, you're exactly right. So, yeah, it keeps them from, and y'all hear what James said? What happens is when these things try to break, they create an arc, and a lot of times it'll cause one side to try to fuse. Well, what happens with the double break is that it automatically, that spring, you can see it actually tilts. So what happens if one end don't break, then what the thing does, it'll tilt up like this and break it probably 99% of the time, right? You understand? So these, you really got to weld these things together before they won't break. So that's double break. They can handle a higher current and they break. They don't weld together as easy as single break. Okay, so industrial switches are designed for extreme humidity, flashing liquid, gas and emission, dust, vibration, high electrical noise. Switches create a lot of electrical noise. So these are some of our switches. This guy you're used to. You're not going to run into many of these in the industry. And why is that? You're not going to run into many of these controlling equipment. You'll run into them in shops and stuff like that. But
Light switch.
yeah, but what's the problem with light switch? Well, why don't we see much of those out on the floor in an industrial environment?
It can cause a hazardous environment.
Voltages too high.
Huh?
Higher voltages there.
No, it's just that if you accidentally hit them or something, they're so easy to change the position, accidentally change the position on them. Right? You understand that? Okay. So normally if we use these switches, we use these selector switches and they have detents in them. So now you have to literally grab them and move them this way instead of moving them up and down, right? See a lot of, don't see many of these. Most of them we're going to see is push buttons. Limit switches, we showed y'all some of those. These are mechanically operated switches. So they have an operator on them. The operator's literally got to do what? It's got to make physical contact with whatever it's trying to see, right? That's the symbol for a limit switch. Of course, the limit switch is going to be parked, the device is going to be parked somewhere. And the problem is that some of the limit switches might already be made. or they might already be open. So what we have at the top, we have normally closed and normally open. Can you see, the way they're drawn?
Yes.
That's
So what?
simple for the limit switch right there.
Yes, that's the symbol for the tree. So it's got the little plateau, I guess the little ramp up here. Right.
Mm-hmm.
So at the top we have a normally closed. Notice, and what you do, guys, you're looking to see what gravity's trying to do. So what on the top one, what's gravity trying to do? Trying to close it, so it's a normally closed switch. If you look at this one, gravity's trying to open it, so it's a normally open. Now, what we do is we draw the limit switches at the normal position of the equipment they're on. Does that make sense? So sometimes that thing might be up on this thing right here. This is where it's parked. So notice gravity's trying to close it, so it must be what? Held open. This, gravity's trying to open it, so this must be what?
Close.
Held closed.
Hell close.
Held closed. So this is what they're talking about here. So when the machine is at its rest, this guy is closed, right? You understand that? So that's why we have these four symbols. We have normally open, normally closed, then we have normally open, held closed, and normally open, held open. Are we okay? Yes, no. Temperature switches. In fact, what we're going to do, guys, since all we have on our trainers are push buttons, what I think I'm going to do is I think I'm going to stop this lecture right now and get y'all into the next lecture. Let's go to the next chapter. Because we'll come back and pick up on this.
Chapter 5.
Trying to do that.
Yeah, what I'm trying to do is trying to get y'all into lab.
I heard you.
Creating related
Where we at
logic
now?
diagrams.